Hi there, Mr. Holcomb here with another lesson in pre-algebra. This is Unit 5, Lesson 3, Session 1, Subtract Integers and Rational Numbers. Okay, learning targets include I can determine the sign of the difference of a subtraction expression. I can use a number line to find the distance between two rational numbers, and I can model subtracting rational numbers using a number line. So, what's the score? Rebecca is in a year-long competition with her classmate Marissa. The table shows the points each student earned in the first 2 weeks of the competition. How many points does each person have at the end of week 2? So, what we're going to look at is Rebecca first. So she has 220 or 2.25 points week 1, and then she has negative 4.5 points on week 2. How much does she have at the end of week 2? Well, what this is we're going to take 225 and we're going to subtract, or we're going to add a negative 4.5, which is subtracting 4.5. Okay, so if we do this with a number line, it's going to look like this. I always look at the decimals when I'm creating my table or my number line, and it's 0.25 is a quarter, 0.5 is a half. So we're going in quarters. So we're starting, we need 0, and we're going to go up 1/4, 1/2, 3/4, and then 1. 1 1/4, 1 1/2, 1 3/4, 2. 2 1/4, 2 1/2, 2 3/4, 3. Okay, our first week, we got 2.25 points from Rebecca. So that's positive, so I'm going to use green. I'm going to go to the right from 0 to 0.25. Might want to pull this a little bit further, right there. Okay, so we started at 0 and got to 2.25. And I'm going to write that above it, just so we know what that represents. Okay, her second week, she went the other direction. She was negative. Okay, so we're going to start at 2.25, which is right here, and we're going to go the other way. Oops, I thought I chose the other direction arrow, but I can fix that by moving this. So we're going to put it back here. We just need to determine how far to the left we have to go. So here's a quarter, a half, 3/4, and -1. A quarter, a half, 3/4, -2, and a quarter and a half and 3/4 and -3. Okay, so going back here is 2.25, and this would be 3.25 to here. 0 is 2.25, -1 is 3.25, -2 is 4.25, and then another quarter would be 4.5. So we're going to end up at -2.25. Okay, and we're going to give this value a -4.5. So we went right 2 1/4. She got 2 1/4 points the first week, but the second week she lost 4.5, and she ended up at -2.25. Okay. We're now going to do the same thing for, let me just move these out of the way. Actually, let's just erase those. Okay, and I'm going to make a copy of this. That's not going to work. Let me try one thing first. Okay, so I just had to make an adjustment to my background here. Okay, that's what I was trying to do. Okay, so now we have a new number line. Okay, these numbers are different though. The first number is -4. Okay, and the next number is -6. So maybe I can't use this at all. I'm going to get rid of everything here. Okay, and we're starting at 0. So actually, I want my number line to start at 0. Just move this. Okay, so what we're doing here, I'm just trying to get my set of numbers to be over here and then bring this down like so. Okay, that's better. So what the reason I'm doing this is because I look and I see Marissa's going -4 points her first week, but then the second week she lost another 6. So actually, I don't even want to use any of these numbers here because it's not quarters. These are integers, so let's just deal with integers when we write this. So this is -1, -2, -3, -4. Okay. So my first arrow is going to start at 0 and it's going to end at -4. And I'll write the length above it as -4. Okay. Second week, we're starting at -4. So this is -5, -6, -7, -8. Okay. -9, -10. Okay, the reason I went beyond that -4, 8 is because this says it's -6. So if I make this arrow a length of -6, then we'd have -4, week 1, -6, week 2, ending up with a total of -10. Okay. So Rebecca had a -2.25 points after 2 weeks, and Marissa had -10 after 2 weeks. Okay. How many points does each person have at the end of week 2? We just did. Do you think each person had more or less points after week 2 than they did after week 1? So if I go back, okay, week 1, all you have to do is decide if you were to the right or left of this value here. That's the end of week 1, and this is the end of week 1 for Marissa. Rebecca was here after week 1. If you're to the left, you're less, and if you're to the right, you're more. Well, they were both to the left, so that means they both had less. And the reason why, I basically just stated it. Their second week scores were to the left of their first week scores. Okay. So if we use a number line, this is just the number line that they showed that I've already created, so I'll skip that. How could you use a number line to determine how many points Marissa has? I've already done that. -4, then another -6. So let's use the additive inverse to determine how many points each person has at the end of week 2. That way we don't have to do models. So to subtract a rational number, add its additive inverse. So if we have P minus Q, well, that's the same as P plus a negative Q. So Rebecca, let me highlight this to explain it. 2.25 for week 1 minus 4.5, which is the same as plus a -4.5. Okay, so minus 4.5 right here is the same as plus a -4.5 here. Marissa, -4 minus 6 is the same as plus a -6. Okay. Rebecca ended up at negative 2.25. Marissa ended up at negative 10. To subtract a rational number at its additive inverse. P minus Q is equal to P plus a negative Q. P minus Q can be defined as the missing addend in Q plus some number equals negative 4. For example, you can think if negative 4 minus 6 equals some number, then 6 plus some number equals negative 4. So let me explain what they're doing here. I have negative 4 minus 6 equals blank. Okay? And actually, let me rewrite that. Negative 4, I just need to pause because I'm making these different components. When I drag, they don't all move. Okay? So what they're doing here is they're moving the 6. So whenever I move a number over to the other side, in order to move it, I have to add. I have to do the opposite. So to get rid of 6 here, I've got to add 6 to it. So negative 4 is by itself because this is 6, 0 pairs, if you will. But I can't add 6 to the left and not add anything to the right because then the equation's no longer true. So I'd have to add 6 to both sides. So what would happen there is I get plus 6 over here, and I get a 0 pair here. Okay, so all of these go away. So then I get negative 4 equals 6, and this should actually be here, plus some number. Okay, so that's all they were doing here. They just moved the 6 over to the other side of the equal sign. Okay, it was over here with negative 4, and then they also flipped it. Now negative 4 is on the other side. So there is a property where it says if A equals B, then B equals A. Okay, and that's symmetry. So 6 plus what equals negative 4? Well, it's going to be negative 10. Okay, so what they're basically saying is if negative 4 minus 6 equals negative 10, then 6 plus negative 10 will equal negative 4. Hopefully that wasn't confusing. So what do you notice about these two equations? All right, so let me get my highlighter out. We have a negative 12, but on this one it's positive. We have a positive 15. On this one it's negative 15. And we have a 3 over here, and we have a negative 3 here. So how can I get this equation to be this equation? So in other words, negative 12 plus 15 equals 3. How do I make that become 12 minus 15 equals negative 3? Okay, my class had a bit of a struggle with this, but all you have to do is either multiply or divide by the inverse of the identity. And the multiplicative or additive identity is 0, but the multiplicative identity is 1. So if I multiply this by negative 1, a negative 1 times a negative 12 is positive 12. A negative 1 times positive 15 is negative 15. And a negative 1 times a positive 3 is negative 3. Okay, so I notice that these are additive inverses of each value because I can multiply by negative 1 and get the new value. Okay, that brings us to the end of session 1. Okay, welcome to another lesson in pre-algebra. This is lesson 3, session 2 from unit 5. Subtract integers and rational numbers. Be curious. How are they the same? How are they different? Okay, well, this is temperature Celsius, and it looks like these two are equivalent because it's turning red at 95, and this is turning red around 95, 90 to 95. So this is Celsius vertical, and this is Celsius on a horizontal. Where over here we have one thermometer with different readings on both sides, and as you can see, one is Celsius and one side's Fahrenheit. And they're both, it's just one vertical representing both values. So that's the difference and that's the similarities. Okay. So roving on Mars. One of NASA's rovers on Mars recorded a high temperature of 95 degrees. Okay, that'd be like a nice day here. Fahrenheit. And a low temperature of negative 166 degrees Fahrenheit. Now that's cold. What is the range in temperatures on Mars? Keyword here, range. Range, by definition, let me write it over here. Range equals the largest number minus the smallest. Okay, so 95 minus a negative 166 degrees equals. Okay, so now I want to start talking about double signs. Whenever we have double negatives, it means minus a negative is the same as this. Plus. Okay? 6 plus 5 is 11. Carry the 1. 9 plus 6 is 15. Plus that carried 1 is 16. Carry 1. 1 and 1 is 2. So the difference between 95 degrees and negative 166 degrees is 261 degrees. Now let's do this with a number line. And since I'm a little low on space, well, maybe I'll do it here. Did you catch that pun, by the way? Low on space, we're in Mars. Get it? Okay, so our high temperature is 95 degrees. So I'm going to put this up here, 95. Okay, somewhere we're going to get cross zero because we went to negative 166. So in order for me to do this on a number line, okay, we always start at 0. And the high temperature went up to 95 degrees. Okay, so this is 95. But then things go south. Okay, the sun sets or whatever the sun does on Mars, and we're going to turn and then we're going to go down to 166 from 95. So let's think of that as two distances. How far is 95 from 0? It's 95. How far is 166 from 0? Well, it's 166. So what am I doing here? I'm taking the absolute value of 95, which is 95, and I'm taking the absolute value of negative 166. Whoops. Let's try that again. Oh, it erased everything. Absolute value of 95 is 95. The absolute value of negative 166 degrees is 166. So if I add those, I get 11, 16, and 2. So as you can see, we get the same value. Add the absolute values and you'll find your range when the signs are different. Okay, I'll skip that. So here's a number line like I just did, the absolute value of negative 166 and the absolute value of 95, and then add the two, and we get the range to be 261. In this case, it's degrees. Okay, I believe it was degrees Fahrenheit. So they said units here, but I don't agree. Okay. It's not units. It's degrees Fahrenheit. Okay, how could you use the additive inverse to determine the range? Well, we could take 95 plus a negative 166. Okay. How could we use the additive inverse to determine the range? Okay, well, it's on the next slide. Let's take a look. Or is it? Maybe they didn't do it here. Okay, so here's what we were given. High of 95, a low of 166. We don't want to add. That was my mistake here. It's subtract. Okay, but here's what we can do. We can take 95 minus, and then here I can break up 166 as a negative 95 and a negative. So 95 to 100 is 1. Okay. I'm sorry, it's 5. Wait, let me think this through a second. I have a positive 95, so therefore I want a negative 95. And to get to negative 166, if I already have a negative 95, then it's going to be plus a negative 66 plus 5 more, which is 71. Okay. And that's supposed to be plus here. So 95 and negative 95 cancel, but that only gives us 71. So how can we do this to get this to come out? Using additive inverses. Okay. Okay, so I had it right. I was just thinking about this. This is supposed to be minus. So let me just get rid of all this. So all we're really doing is we're taking the additive inverse. So 95 minus a negative 166 is going to be the same as 95 plus 166. So all they're really talking about is taking the additive inverse of the negative number and combining these two terms, and we would end up with 261. Okay. That's all they were basically saying. Take the additive inverse of the negative value. Okay. How would the range change if the high temperature was negative 95 instead of 95? So before we had 95 degrees as a high and negative 166 as a low. Now we're saying it's negative 95 and negative 166. So range means the difference between the high and the low. So it's negative 95 minus a negative 166. But that's going to become negative 95 plus 166. So if I did that with a number line, like so, okay. So here's 0. Actually, let's move this over here because we're not going to go positive. So here's 0 degrees. Where's negative 95? Okay, so our first number, we want to go left of 0. Let's just say this is negative 95 right here. Okay, so that will put us at negative 95. All right, and now we want to go down to negative 166. So that would give us another number line, another line on the number, on the number line, another line on the number line. Going down to 166. Okay, so in this situation, I don't really want this one because we're only going from negative 95 to negative 166. Okay, how far is that? Well, let's take the absolute value of negative 166, and that's 166. Take the absolute value of negative 95, and that equals 95, and then subtract them, and we get 71. Okay. So to subtract an integer, add the additive inverse. P minus Q equals P plus a negative Q. If I had 17 minus 20, that's equal to 17 plus a negative 20. The distance between two numbers on a number line is equal to the absolute value of their differences. So notice what they have here. 5 minus 3, the absolute value of 5 minus 3 is equivalent to the absolute value of 2. And therefore, the absolute value of 5 minus 3 is equal to 2, because the absolute value of 2 is 2. Now, if I switch these around, 3 minus 5 is equal to negative 2. And the absolute value of 3 minus 5 is therefore equal to 2, because the absolute value of negative 2 is 2. So the absolute values of each one of these is the same, or the distance between 3 and 5 is 2. So it doesn't matter order. You could say 3 minus 5 and get negative 2, take its absolute value, the distance is 2. Take 5 minus 3, get 2, the absolute value of 2 is also 2. So the distance, regardless of what direction you're going, is going to be a distance of 2. Whoa. Okay, now we're over in Africa talking about a shepherd's tree. Africa's Kalahari Desert is home to a tree known as the shepherd's tree. I did not know about this before today, and it's pretty amazing. This type of tree can grow to be 33 feet tall. Nothing too amazing about that. It's an average tree here. However, the roots go down 223 feet into the ground. What is the distance from the deepest root to the top of the tree? So this from here to here is 33 feet. Can't really see drawing in here. 33 feet just from the top of the tree to here. But then the roots system is coming down like this, and they're going down a nut all the way down here. And the distance from here to here is 223 amazing feet. Okay, looking for water. It's arid in the desert. All right, so how are we going to do this problem? Well, let's try a number line. Okay. I need a 0 in this case, and that is going to represent our ground. And I'm going to need a top of the tree, which is 33 feet. And I'm going to need the bottom of the roots, which is negative 233 feet. So what we're really doing is we're going from 33 down to 0, and then 0 down to negative 233. So this is 33 feet in the negative direction, and this is negative 233 in the negative direction. So I would say 33 minus a negative 233. Remember, the range is the greater minus the least. And so this would be 33 plus 233, which is 266 feet from the bottom of the roots to the top of the tree. Okay. Okay, that brings us to the end of lesson 3, session 2. Thanks for watching. Have a great day.